Hi, everyone. My name is Knox. I'm a product manager on Chrome's web platform team. I focus on making the web an easier platform to build on, which is what I'm here today to talk about. So without further ado, let's jump right in. Now, I may be a little biased when I say this, but I think the web is one of the most amazing things humans have ever built. Now, when I say this, I mean the web, not just the internet. Now, to be true, the internet is its own wonder, but the web is an open computing platform that stood the test of time, and that's really humbling to me, right? The web is on every desktop. It's in every user's pocket. It's on our wrists. It's in our homes. But we got there through collaboration and consensus building. We worked across individuals, businesses, even governments to develop a commons that's not owned by anybody, but certainly nurtured by many people along the way. And I don't think there's any other platform like that. So on Chrome, we're really proud to play a leadership role in the web. But it always sits in this context, right? The web's strength stems from that collaboration and openness. So this talk is about something that we're excited to share with the web community. But more than anything, it's about starting a discussion. Because once the web community gets involved, that's really where things start to matter. Now, the web's success carries with it expectations. As technology is increasingly embedded in every part of users' lives, they're expecting more and more from the digital experiences that they interact with. It's not just about the content or service you provide anymore. Everyone is in on the game these days. You need to delight at every point if you want to keep up. And this isn't just a thought experiment. We've seen again and again that people who put the time and effort into delivering on these expectations reap big business rewards. You can't afford to stand still, or someone else is going to grab the opportunity. Now, while requirements are increasing across the board, we see three big areas where user expectations are ramping up rapidly right now. Users want their sites to load instantly. A study found that 53% of users will abandon a site if it takes longer than 3 seconds to load. You could be losing half your customers before they've even seen your site. But delivering these kind of load times is really hard. Chrome's official recommendation is only 5 seconds. We know how hard it is to hit this 3-second target. But the impact of getting these load times down is very real. Internal Chrome data shows that 20% of all mobile Android page loads are abandoned because a site takes too long to load. And that's not a specific page set or anything. That's 20%, 1 out of 5 of all page loads on mobile is abandoned. Now, the next area where user expectations are skyrocketing is the quality of your site's interactions. And user expectations here are really draconian. In order to avoid any negative user perception, you need to respond to every input within 50 milliseconds. And no matter what your site is doing, you need to run animations at 60 frames per second. Now, it's true the quality of your site's design is tougher to nail down than something like loading speeds, but that doesn't make it any less important. As we mentioned in the web keynote earlier today, Pinterest improved their own engagement metrics by 60% when they revamped the quality and performance of their website. And if these issues weren't enough, users increasingly expect your service to be accessible everywhere. That means all of their devices, their phone, their laptop, TV, smart speakers, you name it. But increasingly, it also means across all of their services, things like Facebook or Snapchat. This leaves you delivering increasingly higher quality while supporting an ever-growing matrix of development platforms. So we think that these problems represent 3 big opportunities for the web to go further than simply making things possible. We want the web to actively support you in finding success with these 3 key areas. How quickly does your experience load? How high quality is the design and interaction of your page? And where can users find you? Now, this all might seem daunting, and we certainly have our work cut out ahead of us. But web developers have a leg up on everyone else here. PWAs and the web generally leave us well positioned to embrace these kinds of new user expectations. For example, Book My Show's PWA is 180 times smaller than their iOS app, which makes it much simpler to meet that 3-second load benchmark for first-time users. And in terms of building high-quality UX, new users on Make My Trips PWA convert 3 times as often. And technologies like Service Worker or the purple loading pattern give you unprecedented control over how you deliver your app. Combined with add to home screen and push notifications, this lets you deliver deeply engaging experiences that can load instantly for users. And perhaps most obviously, the web is cross-platform by default, right? And that's been true since the very beginning. Being everywhere is built into the web's DNA. It's just how we do things. So building a PWA and choosing the web is like starting 100 meters down the track. But these technologies, they only make it possible to build incredible pages. And the power and flexibility of the primitives I just mentioned, for a lot of people who just want to get their business out there, they just want to focus on delighting their users, these can be unnecessary. They just make building their site more complex. So we think that the web can do more to make incredible pages easy to build, not just possible. So let's talk about what we're doing to make them easier. To start things off, let's hear from my colleague Stephan about what we're doing to create more options for content delivery.
Hi there. So my name is Stephan. I'm also a product manager on the Chrome platform team. And today, I'd like to talk to you about some standards-based technology that we're very actively working on right now to improve how to deliver content on the web. If you look at this very standard progression of sharing a link with a friend via chat, you get the link through the menu, you paste the link, we provide a nice screenshot of it. But wouldn't it be cool if we could share the actual content rather than merely the link? What we'd like to be able to do is to save the page or potentially a web app, just like what Drew was talking about. This allows for useful new applications, for example, offline PWA installs. What we need is a way to distribute content on the web that doesn't rely solely on it coming from exactly the same place that it was originally published from. Now, as useful as this notion is, we also need to make sure we don't break anything while we're doing all this. So we don't want to break attribution. We don't want to break things like integrity. So in order to do that, we're working on some technologies under the umbrella of web packaging. This is currently being done as part of the IATF standards development process. Web packaging is currently an IATF draft. And we think this collection of technologies and this approach is going to be a very powerful new set of primitives, which allows for simpler loading architecture and potentially very interesting new use cases. So the first step along the way to getting web packaging is this notion of signed exchanges. Signed exchanges provide a way to associate stored content with its origin in a way that's verifiable and secure. A signed exchange is basically an HTTP exchange with a digital signature wrapped around it. It has a number of notable features, one of which is the duration of validity, how long this web package is in fact valid. We want to create a default mechanism that encourages the browser to verify at appropriate intervals that the content is still the most current. If the package has a problem or if it has a very short content half-life, you want the user not to have stale content. You want to have a guarantee of integrity. So there's a hash in there, which is, again, within the scope of the digital signature. And the hash tells us that the content has not been changed in any way since it left the publisher. And finally, within scope of this signature is also the web origin of the publisher. This is going to come in handy very shortly. Now, in the future, we're still working on it, so there's still stuff that needs to get done. we will also have things called bundled exchanges. Bundled exchanges have all the characteristics of a signed exchange, plus they actually come with all the assets. So it's everything that you wanted with some guarantees about provenance and about integrity. So let's imagine a near future world that has web packaging. Let's say we had, a news aggregator, for example. And let's call it Google Procrastinator. You subscribe to a bunch of content, you have headlines delivered to you when you want to procrastinate, and it all just seems like a very straightforward type of application. Now, for a site like this, there are several facets of web packaging that can serve you very, very well. Now, imagine we have a friend, Dave. Dave is very enthusiastic. Dave is also a bit of a clickbait cannon, so he tends to send us lots of links with very hyperbolic introductions. And so he says, this is a mind-blowing article. Since his success rate is generally pretty good, we're going to click on this link. So when we do, this is what we get. It turns out Dave was right. This was a mind-blowingly popular link, and the originating server collapsed under the load. Now, let's imagine this was a site that you already subscribed to in Procrastinator. Our server, the Procrastinator server, could very well have already downloaded a bundled exchange with all the content that belongs to that page, and it can then display it for you. The site is down or super, super slow, but you're still getting your content because the article, the CSS, the images, it's all coming from the Procrastinator servers as part of the web package. No matter what happens, the content is available, and although this content is served by someone other than the original publisher, you still have the guarantee that it's the same thing that the publisher originally sent out. Now, what happens if we have no connectivity at all? Fortunately, it's open web all the way down. So if there's no connectivity, it turns out we're using a service worker to render this. And the service worker can cache resources, one of which can be the bundled exchange. So despite the fact that the originating blog server doesn't intrinsically support offline, by using these mechanisms, you effectively get offline reading for free, which is incredibly handy when your connectivity fails or you're in an aircraft without Wi-Fi. Now, this is a visualization of a potential future of web packaging, including bundled exchanges, which are a little ways off still. But let me give you a much more concrete example, a much more immediate example as well. Now, when AMP appeared on the scene about 2 years ago, it proved that we could deliver a user-focused, snappy web experience. And if you were at the State of the Web session earlier on, the median load time and display time of an AMP page is still very, very low. One thing that didn't work out so well with AMP was the user confusion caused by seeing a page from a publisher but not having that publisher's URL in the address box. So let's see what happens. In an old pre-world, we look up chocolate chip cookies, we find an AMP page which has the recipe, and if we look in the address bar, it still says google.com/AMP. This is today without web packaging. It's not ideal. So in a world with web packaging, we enter the same query, chocolate chip cookies. We get the same package. In this case, Chrome is telling us web packaging is involved. That's what that blue banner is. We'll tap on the recipe. It's the same thing. It's very responsive. And when we go up into the address bar, it shows Food Network rather than Google. A lot of technology behind the scenes to make this happen, but the user experience is one where there is no longer any confusion, where it's very clear where the content is coming from. At this point, I'd like to give a shout out to our friends at Food Network, who sunk a bunch of time and energy into getting their content ready and working with our tooling to enable this particular demo. So we'd also like you to try this for yourself. It wouldn't be very sporting if we just kept all this to ourselves. So if you are using Chrome Beta or Dev at the moment on Android, there is a flag that you can flip to enable signed HTTP exchanges. The Chrome loading team, which is based in Tokyo, has been doing a ton of work to make this happen. You can try this out on your own. If there is other tooling available to help create some of these sign exchanges, and in combination, once you flip the switch, you'll be able to test it out for yourself and get a better sense of how this technology works. For those of you who are interested in delving even deeper and really understanding the full scope of web packaging, I'd encourage you to take a look at the spec here at this link. And there's probably way more information than you will immediately know what to do with. And with that, back to Drew. Thanks very much.
All right, thank you, Stephan. How's everybody feeling? Good? About halfway through or so, so we'll power through. Now, we just heard about how we're thinking about making loading easier. But let's talk about how we're going to make it easier to build pages that stay fast and responsive after they've loaded. And when I think about what makes this hard on the web today, I think of an overgrown jungle. Now, the web is a 30-year-old platform, and it's focused on backwards compatibility for most of its lifetime. Now, don't get me wrong. This is a huge strength, especially for the stability of your business. But it also means that there's a lot of cruft that we've accumulated along the way. And if we go back to that person who just wants to delight users, they're just trying to get their business out there, if you're just going from point A to point B, there's a lot of best practices and rules of thumb that you need to keep track of to keep your page successful. And this reminds me of board games versus video games. Now, video games track a bunch of rules on your behalf. And this allows them to have far more complex experiences and interactions. On the other hand, with board games, you find yourself spending a lot of time just moving things along, making sure the rules are being followed. What if the web did something similar to video games? What if we could make the platform aware of all these rules and best practices that you keep track of today, and then based on your needs and goals, you can ask the browser to manage any of those automatically on your behalf. Now, before I go any further, there are a lot of tools out there, like Lighthouse, that help track best practices. And these tools will continue to be vital. They can be much more opinionated than the bare platform, which allows them to take you further and give you bigger performance gains. They can also offer more holistic analysis techniques, like the Lighthouse report. But we want developers to be able to jump right in and start building their websites. We don't want them to have to commit to an entire tool chain up front. So we need something that doesn't require any configuration, that catches problems from the first line of code you write. We want something so that when you apply Lighthouse, your very first score is even higher. And to achieve that, we think that the web needs to make these best practices available directly in the platform. Now, we're not just guessing when we say this. Google's own internal JavaScript development framework has best practices baked directly into the platform's API surface. This means things like removing dangerous APIs or prohibiting calling patterns that are performance or security anti-patterns. If you use React, you'll be familiar with something similar of dangerously use inner HTML, right? They try to get you to avoid certain APIs. And we found that these rules make developers more productive because they catch errors earlier. They also improve the security of our sites. We found that when we turn these rules on, we reduce cross-site scripting vulnerabilities in flagship Google products by over 75%. So we're eager today to start a discussion with the rest of the web community. What are the best practices that make the most sense for the web? And what's the best way to build them into the web's platform? And we think feature policy is going to play a big role here. Feature policy, for those who don't know, is a cross-browser standard that's currently implemented in Chrome with positive signals from other browsers. Feature policy allows the browser to express features of the web as a configurable policy. This introduces an allow attribute, where we as the developer can specify what features Chrome should disable. A concrete example shown here is disallow sync XHR, which is available in Chrome today. You can see it used on an iframe here, but you could also specify this policy site-wide with a request header. But essentially what's happening is by enabling the sync XHR policy, anyone who tries to use the synchronous XHR request will immediately get an error. Even that new hire who's still learning the ropes and doesn't really know that synchronous network access is kind of old school. Now, we want to go further than this, though. We don't just want to turn off APIs. That's only half the battle. We want to create policies that allow you to control more abstract best practices. Things like images must have sizes, or don't render content that's more than 3 window heights off screen. And we think there are 3 areas that will be a good fit for this. The first area that we think there's a lot of opportunity is images. A survey of 1,000 sites found that 25% could save 250 kilobytes just with straightforward image optimization techniques. On median network connections, that's about 5 seconds of load time. That's 5 seconds you could get back with essentially no extra development work. So we want to make it easier to find these kind of low-hanging fruit and to tackle them incrementally. So we have 4 policies that we've been working on recently. The first requires all images to have sizes. This prevents the user experience from jumping around as new images load and resize the page, because the browser knows ahead of time how big those images are going to be. Next, we have a policy that requires modern image formats. This makes sure you can take advantage of the fast decoding and high compression rates of modern images. Next, we have a policy that prevents image downscaling. So it can help you avoid things like loading a desktop image on a mobile device. And finally, we have a policy that detects poorly compressed images, highlighting them to you for further optimization. Now, with each of these policies, what happens when an image violates the policy is that Chrome renders it in inverted colors. So as you're testing your site and as you're looking at what's going on, you can immediately see those images that need further attention. And we're still refining the exact shape of these APIs and figuring out the best way to bake these policies into the platform so that they're useful to you. But we're eager for feedback, and so we have a few policies available in Chrome flags. If you go turn on the experimental productivity features flag, you can get access to explicit image sizes and modern image formats today, with the other 2 I mentioned coming soon. And the next big area for improvement is reducing payload size of websites. Oftentimes, a big site payload is something that accrues slowly over time. There's not just one massive resource. We wanted to help infrastructure teams set budgets that they could enforce across their website automatically, so that as each little regression came in, they could catch it and prevent it before they needed to do a full site redesign. So similar to feature policy, we're introducing something called size policy, which creates an attribute that allows you to limit the size of each individual resource type. You can say things like, images should never be larger than 100 kilobytes, or JavaScript files should be smaller than 2 kilobytes. Now, the specificity of these policies allows you to track down individual regressions as they're committed. But the per-resource flexibility means that you can set whatever policies make the most sense for your site. If you're a multimedia site, you're obviously going to set bigger policies than a news site. And the last area that I want to talk about today is animations. We want to give developers the ability to specify which properties are safe to animate. Now, as site requirements and browser implementations evolve, you can fine-tune which properties you want to allow. But as a proof of concept to show here today, we have a policy that only allows accelerated animations, like transform and opacity. These animations can run smoothly no matter what's going on for the rest of your site. Now, like I mentioned before, this policy is available behind the same experimental productivity features flag. OK, so I just ran through a bunch of different policies. If you're interested, you can try them behind a flag, like I mentioned. But you can also go to this link to find more precise API documentation and information on how to start using these policies in your development environment today. And what really excites me is because these features give most of their value at development time, you can start using them and experiencing them even though they're behind a flag. You just turn them on while you're developing. But most important is that we want to start hearing feedback on what use cases we're missing and which policies are the most exciting. So please go to the GitHub repo, file issues, express support for what matters most to you. All right, now automatically tracking best practices is only part of the battle. Another problem is that the web comes with a lot of assembly required. Now, this is great for those of us who want to experiment and push the platform to its limits. But again, going back to that person who's just trying to get from point A to point B, it makes things really difficult if you have to build everything yourself or find that perfect library from a third party. And it's even harder when you think about trying to keep the size of your site payload small. But traditionally, the platform has shied away from building high-level productivity features like this because they're easy to get wrong. Anyone who knows about app cache will probably agree. And they increase the cost of the runtime even for pages that aren't using the API, right? Everything is global on the web. But we think that there's a way to provide more of these high-level features while avoiding these problems. And we're calling the idea layered APIs. Now, as a brief aside, it turns out that JavaScript modules provide a pretty good set of characteristics for solving this problem. The features and the modules are imported, so you only pay a cost for what you use. And JavaScript has no special privileges. So if an API doesn't fit your needs, you're not left with nothing else to use. You can just dig in and build something that works for your use case. Anything the module could do, you could do too. It's really just there for your convenience. So layered APIs are just ordinary web platform features, like a div or IndexedDB. But they have one really important twist, and that's that they have to share the same discipline as a JavaScript module. They must be imported, and they can't do anything that plain vanilla JavaScript couldn't do. Now, that doesn't necessarily mean they'll be implemented in JavaScript, but they behave identically. So instead of specifying a remote URL, you specify a standard platform identifier, but using the same module import syntax. It just loads a feature shipped with the browser. Now, layered APIs, because they only do what JavaScript could do, they are easy to polyfill right out of the gate, which is why we're including a fallback syntax baked in. So on browsers that don't support the layered API, you get graceful degradation without having to worry about feature detection or doing anything special. It just works the same. But on browsers that do support a given layered API, there's no data to load off the network. It's like a standard lib, but for the web. Now, this is an area that we are actively exploring. So we've built two prototypes for layered APIs. An infinite list component that we're calling virtual list, and an async local storage API. You can turn these on using that same experimental productivity features flag I mentioned for policies. Speaking of turning things on, we tried building something with these ourselves. So for any of you who've tried to take a look at the HTML spec page, which admittedly might be a small group, it's huge. It takes a long time to load, and you're frequently staring at a white screen as you try to scroll, because it's loading a lot of text all at once. So you can see here on the left the normal HTML spec page. And then on the right, using the virtual list layered API to incrementally load content as we go. You can see that it loads much more smoothly, right? We don't see these white screens as often. What we're getting here is a modern, incremental loading, view recycling, infinite list implementation. And it didn't require loading a third-party library or writing any custom code. This worked right out of the box. Now, again, this is just a prototype to vet the concept. We're eager to keep working with browsers and the web community to understand layered APIs generally and the specific shape of these APIs. But key to that process is feedback from you. So take a look at this link if you want to find out more about layered APIs, and try them for yourself with the experimental productivity features flag. Just make sure to provide feedback in the GitHub repo to help us evolve this in the best way forward. OK, the last topic that we mentioned was getting your content everywhere. So here on Chrome's web platform team, we want to make it easy for you to author one definitive experience. We want it to be portable, high quality, interactive, even if a user comes to that experience from somewhere other than your top-level URL. And we want to make it easy for other services to embed that content and all of its interactivity while preserving users' privacy. Web packaging is a key first step here, right? The signed exchange allows you to make sure that all resources are attributed to your site. So they use your cookies, they use any storage partition you've set up. And they also allow you to eventually bundle all your resources into one easily shareable package. But we want to go even further than that. We want to allow different sites and authors to move seamlessly between one another. This means things like fluid animations from one page to another, even if they're separate domains. And it means moving from an embedded interaction to a full-page experience without losing any state of a user's interactions while you are embedded. Now, designs here are still evolving. So if this sounds a bit vague, you're not alone. Think of this as a sneak peek or a call to get in on the action. We have a proposal, and we are interested in starting a discussion around it, but we need to hear others' thoughts before we really know what it's going to look like. So if you're interested in how we build something between an iframe and a link, something that sits in that middle ground, go to the link here and join the discussion. So instant loading, high quality design and interactions, getting your content everywhere. These things are quickly going to become table stakes for successful web experiences. But we want to make it easy to make this transition. We want to make it easy for you to find success with the web. So this is really just the beginning of how we can make user experiences more seamless, how we can foster content discovery and composition while making it increasingly easy to build these experiences. So if you take two things away today, the first is turn on the experimental productivity features flag and start playing with some of the things we've mentioned. And send all of your feedback to the GitHub repos that I linked in the slides.